Thank you very much for your time. In the next 20 minutes, I'll try to squeeze, and it will be hard, some tips and tricks we use in Lumigo to debug our own 100% serverless production environment. Before we start, a couple words about me. 13 years in the software development industry, working on backend and mobile projects, dealing with serverless in the past 3 years, serverless 0 from last January, and unfortunately I didn't have a real chance to enjoy it. In addition, my other passion is serverless CI/CD. I write quite a lot on the subject and really like helping others. We know it's hard, so if you have any questions related to CI/CD, don't hesitate and contact me. So what's in it for me? A good question. Lumigo is 100% production serverless company. We use our own product to monitor our production environment, eating our own dog food. I want to share with you today the tips that we've gathered along the way on how to monitor your environment. Serverless observability is different from the classical non-serverless observability, mainly because you don't have any servers to log into and search for clues. Everything is ephemeral. You need a way to collect the bits and pieces, and you need to know what to collect. It's distributed. A single invocation error in a Lambda does not mean the error lies there. You need to go up the virtual stack. And serverless is not only Lambdas. Serverless is all the serverless parts that build your application. Things like DynamoDB, step functions, and you need to monitor them as well. And it's a new technology with a different set of metrics that you need to know and learn in order to observe it properly. And not all metrics are exposed easily through the AWS interface. And last but not least, cost monitoring is a crucial part in production environments. Without proper management, you'll get bankrupt. So who are we? Lumigo is a platform dedicated to serverless observability. We do that by collecting metrics, traces, and logs and fuse them together to a coherent view. As I told you, we use our own environment for our production observability, and throughout this session, I'll show you how we use it. So let's start with the tips. So tip number one, logs. Logs are expensive. There were times in Lumigo where we paid hundreds of dollars per day just for logs digestion on CloudWatch, especially in functions that runs tens of millions of invocations per day. Originally, we streamed all of our logs for debugging purposes to Elastic through CloudWatch, but due to cost management, we changed the architecture. We do keep error and warning logs in their native form, and we have the ability to raise the specific log level per Lambda. However, we stream all of our logs through Kinesis files straight to Athena. So in cases we need the raw logs, we can easily search for them in Athena. Most of the time, we use our own platform to collect the events and responses from the running functions. So in case something went wrong, we can easily go to the specific invocation and look at the input-output. So let's see an example from our platform. So just a second. So here you can see a transaction that pushes a report. I can easily click on the invocation itself and get the event and response details. Pay attention that this specific Lambda is triggered by S3, so there's no return value, but you can see all the event details. You can see the specific bucket and the specific key. Here, because the key is confidential, we are scrubbing the data, but depending on your environment and your configuration, you can show everything. And the best part that we are not only collecting invocation from Lambdas, we're also collecting HTTP calls. So you, for example, can click on a DynamoDB query or post, look at the details of what query you ran and what was the response. So think about it. It gives you the same ability, just like you've been writing the debug code and the logging code on your own. So what happens if you want to search through the data like you do in Elasticsearch? Okay, so up until now, I'll show you an example where you know how to, when you reach to a specific invocation, you are able to view it. But what happens when you can't reach the specific invocation? You don't know it. So we allow free search on the items that we showed you just now. You can go and use our Explorer. I'll just open it here. And you can easily search for a specific value. So let's say that here I want to search for the specific bucket and search for all the invocations where that bucket exists. So I can click for it and search for it. Now pay attention that the return value give me a snippet of the result of the invocation itself. I can drill down and see more details on the invocation. In addition, the query language is quite rich, so you can search not only for specific keywords or search items. You can actually use things like where the execution was called, how long did it take, and did it add any errors and things like that. And from here, you can easily jump to the invocation itself, like I showed you earlier. So we have a set of various environments that support the production. All of our developers have their own environment to test their code on a real environment. Because we are serverless, there are no upkeep costs. It was imperative for us to allow our developers, while writing the code, to also understand what's going on behind the scenes when something fails. So if developers can't test the code on a real environment, they will never know if it really works in production. So all of our developers signed up and created a personal project through our platform. Creating a new project is very easy and can be done in a click of a button. The developer just install an IAM role and select which functions they want to trace, and that's it. Our system is near real time, so it's very easy to run something and see it immediately, and that's when we use it during development. So let's see a demo Lambda that I've created. So here is a demo Lambda called Hello Python. It's created from the boilerplate that the AWS Lambda console provides. So it just prints a couple of things to the console, and in the end, it raises an exception. So let's try to run it. By the way, it's traced by our tracer, automatically traced. So I didn't have to add any code or change anything. Excellent. So let's go to our environment. So specifically in my test environment, this is the only function that failed. So I can click on it and go to the actual failure. And as you can see, the failure appears quite immediately. So I can easily go to the invocation itself and debug it and start understanding what went wrong while writing my code. The neat part is that it also pulls all the logs that were written in CloudWatch. So you have everything in a nice compact place. And again, you can get all the tips and tricks that the platform gives you. So you can see the specific error, and you can see the stack trace and things like that. Again, without writing a single line of code. It's very fast and very easy, and we use it quite a lot. One of the hardest things when creating a new Lambda is determining the allowed execution time and memory. I don't want to give the maximum 15 minutes because it might cost a lot of money for an AY Lambda, and it might exhaust your pool of available running Lambdas. Same about memory. Too much might make it run faster, but will definitely cost you more money. So what do we do in order to determine the exact memory and execution time? So we use two tools. One of them is Lumigo CLI. It's an open source tool developed by Lumigo, and it has a specific option called PowerTune. And we use it on some of our Lambdas to find the best combination of memory versus execution time. It just simulates the running of your Lambda with different memory configuration, and it measures the execution time and finds the best combination that runs the fastest but costs the least. And in addition, we also have alerts under our belt, sorry, not here, that we activate for each trace Lambda automatically. One is the ability to alert on close to out of memory execution, and we have a similar alert for the running time. So usually we are defining the values according to some preliminary test, the memory and execution time that we do in the lab. And usually we start with underpowered values, and then we tune it according to the alerts on real production data. So, you know, the lab is one thing, but actually running it production and see how it behaves, it's another thing. And this type of alerts also actually give us the ability to find the exact values, making sure that everything is still runs fast enough, but doesn't cost too much money and doesn't exhaust the memory. Sorry. We always try to understand the big picture. Looking only at the specific error and or invocation is not enough to understand why the error was caused and how it affects the business. So for example, here, just looking at the specific error in CloudWatch and the specific track trace doesn't really help me in understanding how the error affects my business and how the error affects my customer. Which customer should I contact and tell him that we've noticed the error and we are taking care of it? So I want to show you a real example on a transaction depicting an internal process in Lumigo. As you can see, it's a very complicated internal process which contains a Lambda invocation and event bridge on other Lambdas that invoke other Lambdas and messages that go through SNS that invoke other Lambdas and so on. But there are three flows here, and the only error that I see is caused due to event bridge. As you can see, the only flow that was affected is the event bridge flow, and I'm familiar with the system, so I know that the effect on production is minimal. So I can actually go into the event bridge and again go deeper and understand the error. So for here, for example, it's an access denied error. And you know, if I was looking only on the Lambda itself and only on the error of the Lambda, I would see only this red dot in the middle of the screen. So think about it, I'm waking up in the middle of the night and seeing that a major flow in my system is failing, and I don't know how it affects my system. But looking at that, at this entire transaction, it enables me to understand that this specific flow that is broken is not something important. So I can sleep through the night before trying to fix the issue. So it saves me quite a lot of time and worry time. So a quick recap. So too many logs means too much money. Increase the log level and use Athena for cheap search, and use a platform that gives you logs-like capabilities without the extra cost. Allow your developers to easily debug their code while developing and debug the code on a real production environment. Remember, if you haven't run your code on a real AWS environment before releasing it to production, you haven't tested it. Fine-tune your Lambda's memory and running time with a combination of PowerTune and Lambda-specific alerts, and try to understand the big picture to assess priority. So, some final words. You can try us for free on platform.lumigo.io/signup. You have 25% discount for the first year. Just use the following promo code. Read our blogs on serverless, write quite a lot, lumigo.io/blog, and we love to hear your feedback. Contact us, try us, just send us email or contact us to Intercom. We love to talk. With you. That's it. Thank you. And any more questions?